Hello, everybody. Thank you all for joining us today. We've got a couple great talks. I'm not going to waste a lot of time with intros. I'm just going to get straight to it because I think we've got a lot of material to cover. So today we're going to be talking about two really, really hot topics, I think. Both, if you haven't heard of MCP, it helps you build applications using AI. And we have a new LocalStack MCP server, so you're going to get a talk about that and a demo, as well as well. After that, we'll do some Q&A, and then we're going to jump into a talk about chaos engineering. Now, I know you're all thinking like, when is AWS ever down? It's never happened. I've never heard of this, so it's not a concern, but in case it were to ever go down, and that then chaos engineering can help make sure your application is resilient. And so Kiah is going to be giving us a talk talking about like what is chaos engineering, how you can apply that, all those things. So we'll have Q&A after each of those sessions, and then we'll be done. But be sure to add any questions you want to ask about any of the presentations or anything else into the chat, and we will address them at the end of each session. Okay. So with that, I am going to introduce our speakers here, or actually let them introduce themselves. If you've been coming to these meetups, you probably know both of them already, but just in case you haven't, I'll first turn it over to Harsh to introduce himself.
Everyone. I'm Hirsch, and if you have been part of these meetups before, you might have already known me. But just for all of the newcomers, I usually run these meetups, and I just love hosting around these meetups and giving particular talks about some of the new things that we are doing. I'm also one of the developers of the MCP server, and I'm just excited to be talking about it.
Awesome. And Kiah.
Hello, everyone. You may have seen me around a couple of times on these meetups here. I've hosted a couple. I've hosted maybe one, spoken at another. You'll see my face more often as I start, becoming more involved in this meetup. And if you are a part of the Slack community, you have seen my face or at least my avatar a lot. So I guess I would say I'm fairly new ish in comparison to Brian and Harsh. But I've been here for about, I'd say about 6 months or so. Loving it so far. Really excited to be here. Really excited to talk about chaos engineering. So thanks for having me.
Awesome. Well, good to have you both. So I'm gonna let's see, we're gonna the next slide, which is basically handing it over to Harsh. So I will turn it over to you, Harsh.
Sounds great. Thanks a lot, Brian, for the introduction and for everyone who has joined us today to be a part of this meetup. So I'm going to walk you through something that I'm really excited about and I have been pretty much involved in, which is the new LocalStack Model Context Protocol server. So in this session, we will basically cover what it is, why it is such a big deal, and I will be showing some really cool demos of how we are trying to bring AI agentic capabilities to the LocalStack ecosystem and how our developers and our users can basically benefit from that. Oops. Oops. So I missed adding. Yeah, here we go. This is my slide deck. So before we get started, I would just try to just dispel what this whole MCP thing is and what we basically mean by this whole AI agentic ecosystem. So I'm pretty sure you might have seen this meme in different format across a lot of social media stuff going around there. But this is as simple as that. MCP is currently the hottest trend right now in the AI ecosystem. And if you go and check out every company's social feed or all of the new developments that we have been doing, the one thing that pops up quite often is that they are all announcing their new MCP server. So before we get started with this whole MCP thing, it is very instrumental for us to understand what MCP really is. So just for a quick intro, MCP stands for Model, Context, and Protocol. Now, most of you who have been familiar with the whole AI development going about right now, you would understand what model technically means here. Model is basically your large language or your small language model. So think something like Claude or ChatGPT or whatever AI chat tool they are using right now. Now, one of the things that we can all agree on is that they are great at generating content. maybe we can disagree on this fact that most of them are not so great at generating content, but they're all great at generating content. The problem is that they really cannot do anything. They really cannot perform actions. If I can give a particular example right now, and this example came about in one of the AI talks that I was watching, is that when ChatGPT came around, it did not really have the capability to kind of search the web. It was pretty much non-existent. But today, if we kind of come across any LLM tool or any chat tool out there that cannot search the web, it's something that we would consider pretty weird. So this is how fast like the whole AI ecosystem is kind of building on right now. Models are not just able to generate the content, but they can also perform certain actions. And you might have already guessed that these actions are being performed by something that's underneath them. The second part that I can maybe stress on is the context. Now, that's the information that we give the model so that it knows what tools are particularly available to it. This is what so many of these AI chat tools are using these days to kind of do certain things out there. And finally, we have got this whole protocol. Now, as I was saying before, that ChatGPT natively did not have the capability to search the web, but now it has. And similarly, every other tool has got some capability to perform certain actions. We basically need to have a certain protocol, a certain foundation, a particular standard that allows the models and allows these tools to basically talk to each other. Now, this is where Anthropic kind of innovated quite a lot. They came out with a new technology called MCP, which is Model Context Protocol. This came out, I guess, about last year in November 24. And since then, it has like basically really taken off. So the whole MCP thing is all about like how do we standardize how we give LLMs access to external tools. So stuff like Google search, your calendar, or in our case, LocalStack. Now, just to give like a pretty good 10,000 feet view, and this is the best analogy that we can get, which comes right from the official MCP docs, is that MCP is like the USB-C port for AI application. So you have your MCP clients, you have basically got an IDE like Cursor, or you have got a chat interface. And these MCP clients can then connect to MCP hosts like Claude. So these MCP servers basically act as an adapter. So you can literally plug them in into your remote service. So stuff like Slack or your Gmail or your calendar, or even like your local data sources out there. So you can create a server once, and then any compatible AI agent can basically start using those tools. So in this case, like if you look at this diagram, like on the right side of this, we can basically prompt like list my render service. And this prompt gets passed to the Cursor IDE, which then particularly detect the MCP tool or the MCP server that can perform the requested task. And then it connects to the remote render service and it executes that particular action. So this is how we try to enable these LLM tools out there to kind of connect to these remote services and do certain actions on your behalf. Now, MCPs aren't just limited to tools. They also provide you resources. They also provide you prompts, samplings, and a bunch of other things. And the whole MCP ecosystem has been really gearing towards a lot of new enhancements on a monthly or even like on a daily basis. And as you can see over here, MCP isn't just like a vanity thing. It isn't just like a framework or a tool that came about and it might just vanish off in about like 3 or 4 months from now. It's something that has been really getting a lot of traction. More and more, and major companies have started adopting this specification. You have got Microsoft, which has got a massively popular Playwright MCP. You have got the GitHub's official MCP server. AWS, which we in fact emulate on the local machine, has got their own MCP server, about 20 or 25 different ones for every single service, which I like really hate. But it shows that they are all in, and all major players are kind of moving in this direction, kind of trying to make the whole MCP thing the universal standard for AI applications out there. Now, why build an MCP server for LocalStack? Like, why just jump into a bandwagon with every other company out there and say like, hey, we're excited to announce our new MCP server, which we just did about a couple of weeks back. So the fact over here is that LocalStack is incredibly powerful, but the developer experience in this whole new AI world opens up a lot of new opportunities. Now, what we kind of saw when developers were using LocalStack is that they still have to deal with a lot of manual work. For example, if they want to start LocalStack, it is like LocalStack start. If they want to enable verbose locking, they have to see like debug equals 1 LocalStack start. Now, if you want some other customizations, you have to like really craft these very verbose commands with specific flags. Apart from that, if something goes wrong, you basically have to start shifting through thousands of long lines to just find that one error, one regression about what is particularly going wrong with your application. And finally, manually running those deployments for their IAC stack. If any one of you has been using LocalStack before and trying to deploy any IAC code, you would always like understand this. When like CDK local deploy, then you have to like figure out what went wrong, restart the container, do that command all over again, and kind of try to find like where exactly things are basically going wrong. So the goal over here is to kind of create this whole hands-off mode, this sort of an agentic workflow, where a developer could just let an AI take control of their local stack container, and the AI can basically drive the whole development and testing process forward. It's also good because in this case, LocalStack sits on your laptop. It's basically acting as a local sandbox, and you won't have to deal with like a lot of these issues around like, okay, giving it access to the real cloud where it might do something stupid. Everything that the MCP server and the associated AI agent would do, it would pretty much like sit on your machine. And even if something goes wrong, you can just restart your container or stop your container, and you can pretty much like start from the scratch. So this is where I introduced the LocalStack MCP server. And our whole idea is that all of these manual tasks that I was trying to describe all of you, the MCP server can basically transform them into conversational workflows. It can be passed to the whole AI agent, and that AI agent can do certain operations on your behalf. So just as an example of what this MCP server is capable of right now is that you can just imagine having this whole AI partner, and you can technically say to it like, hey, start my LocalStack container. Hey, can you analyze particular service errors in my logs? Hey, can you deploy the CDK or Terraform application on LocalStack? So you can technically do all of this with just the MCP server without having to like really handhold or without having to like really do everything like on a manual basis. So our whole overall idea is that there is your intent and there is a whole action. And this MCP server kind of bridges this whole gap between your intent and the action. And the way that we do it is by fully enabling this whole local agentic workflows for your local stack experience. Now, you might be wondering like how capable this local stack MCP server really is. So this gives like a pretty good bird's eye view of all the tools that we support right now. As of now, we don't support resources and we don't support prompts, but this is something that we are taking a look at right now. But we have got support for about 7 of these tools. I would say the most important one out there sits at the top, which is local stack management. This basically manages your local stack experience in and out. So stuff like starting your container, stopping it, restarting it, doing your status checks, it can do pretty much all of that. The deployer tool is very interesting because it is what deploys your CDK, Terraform, or CloudFormation code on local stack. We have got the whole logs analysis tool. It analyzes your logs. It tries to find out all those errors. It tries to summarize the whole log output out there. And it also like filters those service requests so that you can basically pinpoint what exactly things are going wrong. And finally, we have got the LocalStack AWS client, which is basically there to like run certain AWS CLI commands against your AWS services running inside the LocalStack container. Now, basically like these 4 tools are available right there in the community image. We have got these other tools also, which is like the IAM policy analyzer. Like this basically sets your IAM enforcement levels, and it also generates like your IAM policies. You have got Chaos Injector, which is basically like handling the Chaos API that Kiah would be talking about in the next talk. We have got a CloudPods tool that basically like manages your local stack container snapshots. So these 3 tools out there are basically in the pro service, and you basically need to be on the appropriate pricing tier to be able to use them. But in this particular session, I would try to showcase most of these tools and how they exactly work so that you can get an idea about how you can best get started with them. So now the question would be like, how do I get started with this? How do I configure this? And this is a super easy question. Our MCP server is available right on the NPM registry, and it is distributed using NPX. So all that you need to do is install Node.js on your local machine, and you can pretty much like create an mcp.json file, but that totally depends on what MCP client you're using. If you're using Cursor, it basically involves like going to your Cursor experience, going to the settings, going to MCP integrations, and adding this whole MCP JSON over there. For Q, for Cloud Code, or any other AI tool out there, like the experience might slightly differ, but the fundamentals are really the same. You need to specify the LocalStack MCP server. You need to specify the command, which is in this case is npx, and you need to specify the arguments, which will basically pull this MCP server and will run it on your local machine. Now, as I was saying before, some of these tools will require an auth token. So tools like, let's say, CloudPods, Chaos Injector, IAM Policy Analyzer. So if you have an auth token, if you are a licensed user, all that you need to do is set it through the env block in your mcp.json. So just pass in the whole LocalStack auth token as an environment variable, and you don't have to do any other separate configuration out there. Now, with all of this said, it would be very plausible for me to showcase like how the whole experience looks like. Enough of the slide. So let's get into the quick start and get into a particular live demo. So I'll try to pull out my cursor editor over here. For people like who are not aware about this, Cursor is, I would say, like very much the hottest IDE, AI IDE that you can get right now. You can argue like, okay, there are much better tools out there, stuff like Windsurf or Amazon's new IDE. I guess it's called as, okay, it's Kiro, which is very, very new. But there are like more tools out there. So you can technically get started with any of your favorite tools and the experience will be mostly the same. I'm using Sonnet 4.5 model in this case, but we have mostly tested it across a variety of legacy and the new GPT and Sonnet models, and our experience has been pretty much the same. So you can choose whatever model you feel fit in, and yeah, that should be easy for you to get started. There has been a question on LinkedIn that this MCP server runs also locally, right? That's the best part. With LocalStack, our main emphasis is upon running things locally. So obviously, this MCP server is going to be running on your local machine. Only for certain tools like CloudPods, we do connect with a remote service, but even that happens on your local machine. You don't need to do any separate authentication. Everything can basically like live. Everything is basically being operated through LocalStack's internal APIs. So as a quick start, what I can do is I can showcase how to get started with LocalStack. So I can just pass in like, can you start my LocalStack container? And what happens in the background is that once I pass in the prompt, the MCP client in this case, which is Cursor, it will try to invoke the MCP server tool. So in this case, the tool is basically saying that it has been specified a particular action, and the action over here is start. Now it has invoked the LocalStack management tool, which is pretty much like responsible for all these operations. And once we specified that, it automatically invoked the LocalStack CLI and it started the LocalStack container on my behalf. So no more writing like LocalStack start or specifying any other Docker Compose or Docker CLI command. All it takes is just say like, can you start my LocalStack container? So that's the conversational experience that we are trying to build over here. I can also do like restart my LocalStack container. And what this would again do in the background is that it would stop and it would start my LocalStack container back, just to ensure that we have a fresh state from where we can start. So you can do like a bunch of these operations, like right from your Cursor, from your Claude Code, or even ChatGPT, which now supports the MCP integration. So I can see another thing, like check the status of my LocalStack container. And this would specify status as the action that it needs to take. And it would return like what's the current status of my LocalStack container right in this case. So yeah, that's a runtime version 4.10, which is very much like the new version of LocalStack that we just released about a couple of hours back. So everything is looking good. Our container is now ready to accept requests. So that's all it takes. And it does not like even require an auth token. So you can go on your Cursor, you can go to tools and MCP. That's my LocalStack MCP over here. And that's what it basically looks like. So all that I need to specify is LocalStack MCP server. That's the command, that's the argument. And you can find all of that in our announcement blog post, which I will link on the YouTube live chat, maybe in just a few minutes from here. And in this case, I have specified an auth token. I have just hidden my auth token over here just for my security purpose. But that's all it takes for you to get started with the LocalStack MCP server. So just going back right now and just bringing my slides back. Yes. So I can like do a more expansive demo right now. And in this demo, what I can do is like I can use the MCP to deploy plus test a CDK application. So I'll use the MCP server to deploy like a fairly complex serverless CDK app, which has been built by Brian as part of his AWS for Frontend Developer series. He's gonna link the blog and the GitHub repository down in the YouTube chat, so you can go and check it out from here. But what we will do is like we will prompt the MCP and say like, hey, can you deploy the CDK app? And once it is deployed, we can like further do some extensive rounds of testing just by like running manual prompts. We don't like even need to see any, we don't even like need to run any manual command to do, have it do certain things. So let's go again to my cursor and try to get started with this. Awesome. So let me just zoom it in, and here we go. So in this case, that's where my CDK app lives. The whole CDK app is kind of encapsulated in this DynamoDB stack. And what we're basically doing is we are deploying a CDK app that sets up a DynamoDB table, a Lambda function, an S3 bucket, which has got a website that is distributed using a CloudFront distribution. So what I can do right now is I can say that deploy my CDK app on LocalStack. That's all it takes. And once I invoke this particular like message, what the MCP tool is going to do is like it is going to run the LocalStack deployer tool. And in this case, the deployer tool has got these 3 parameters. It has got an action, which in this case is deploy. It has got this directory. So since I'm located in this particular directory, it just happened to pick that up. And finally, it has got a project type, which is CDK. Right now, the deployer tool basically supports CDK, CloudFormation, and Terraform. So if you have got your ISE code in either of these frameworks, you can pretty much use that. We are trying to expand support for other ISE frameworks as well. Now, for the sake of actually showing you like that something is happening in the background, because we don't really have the streaming support for this setup, what I can do is I can say like localstack logs F with the -F flag, so that I can really follow on the logs. And I can like really show you that things are happening in the background. Like localstack is really bootstrapping the CDK project, then it is deploying all of these resources. And in this case, like the resources are pretty extensive. Once this is done, what it will return is that the CDK deployment is successful, and it is going to share all the outputs. So in this case, the output is going to be the API gateway URL. It's going to be the CloudFront distribution. And if you're like running this app with the MCP server, or even without the MCP server, the app is basically gonna look, I guess, something like this, where it will show like AWS for front-end developers, and the response has been received from the API. So it's pretty much like in and out. Like it allows you to like deploy your ISA project without having you to like run any specific manual commands. It also like returns all the resources that we have just created, which is gonna be DynamoDB table, Lambda function, API gateway, S3 bucket, CloudFront, bucket deployment with assets, and all of these things around here. I can like take this for a short run. So it has got like this whole API gateway URL. So what I can do is I can use curl to kind of just query this particular URL. And it is going to return to me that this particular message, which says like you successfully received data from our DynamoDB table. It's pretty sweet, and it pretty much validates what we are trying to do here. Now, let me show you something more interesting. I can literally tell this MCP server that, can you check, let's go back, can you check what Lambda functions, S3 buckets, DynamoDB tables, and CloudFront distros have been created. So this is where it will try to use the LocalStack AWS client tool. And what the LocalStack AWS client tool does is like it basically generates respective AWS CLI commands, and it directly runs it against the LocalStack container. So you like don't need to have like particularly AWS CLI or AWS local installed on your machine. It's like running everything inside the LocalStack sandbox. So even if you like run things limited within the whole CRUD interface, like creating resource or just like removing a particular resource, you don't have to worry about certain things because everything is being run inside the LocalStack container. So you don't have to worry about your AWS credentials like being passed to the MCP server. That's not going to happen. So it has like listed out all the resources that we were looking for, which is pretty sweet, and that's what we're looking for. So this is where I guess like I can even go a bit extensive. I can say to it like, can you analyze my LocalStack logs and find out errors or issues within my deployment. So again, like this is going to call the whole LocalStack logs analysis tool. It will scrape out all of the LocalStack logs that you have got over here. And it's going to like list out that, okay, these are like all the like happenings that's going about. And if something has gone wrong, if your deployment has particularly failed, it's going to list out to you that, hey, these are the issues that I have encountered. And maybe you can take this action, particularly resolve this particular issue. While we were doing like a lot of internal testing with this MCP server, and we were like using it for a greenfield project, the MCP server was independent enough to take some actions where it involved like going to the logs, figure out the issue, going back to the code and exactly fixing the code based on what the issue was, and just coming back, rerunning the whole deployment and letting us know that the whole deployment is now successful. So that's the kind of agentic capabilities that we are trying to build over here. We already have certain tools in this case that you can use, but we can obviously go beyond that. We can add more tools depending on what your use case is and depending on like what kind of things that you would like to see with the whole MCP server. Given the fact that we are like running a bit short on time, like these are all the things that you can do if you're using the LocalStack community image. If you want to get more of that, we have more MCP tools out there. For example, in this case, we have got, let me just minimize this a bit. But yeah, we have got this whole LocalStack Chaos injector where you can use our LocalStack Chaos API to kind of inject some fault experiments within your infrastructure stack. We have got the whole LocalStack Cloud Pods, and this is going to save a cloud pod, push it to the LocalStack web application, and you can basically distribute that with all of your colleagues. We have got the whole IAM policy analyzer. So you can basically ask LocalStack that, hey, I want my IAM enforcement mode to be pretty strict. So if your service APIs are trying to call to another service API that it does not have explicit permissions for, LocalStack is going to fail it, and it is going to output that into your logs. And again, like, your application can pick that up from the logs. It can automatically fix your IAM policy code and do a bunch of things from there. So hopefully I would get to showcase more of that in some upcoming demo that I can do with some other topic out there. But let's just switch back to our slides and let's get to the whole finishing point. So yes, what are our future plans with this whole MCP server? As I have reiterated before, like, our goal is to basically provide a full sort of like agentic capabilities for the LocalStack ecosystem. And given the fact that we have already gotten so far, our future plans is mostly like going around like expanding the whole performance and reducing the whole log analysis and command time. So in my case, it wasn't that slow, but in some other slower machines, it can be like really slow to get these operations done. We also want to expand the whole deployment support. Right now, we have support only for CloudFormation, for Terraform, for CDK, but we want to expand it to also SAM, which is another AWS framework for building serverless applications, and Pulumi, which is massively popular in our community right now. Building upon the whole IAM policy analyzer, we also want to build a policy advisor. So suppose, let's say that you're building an application and you have got this whole IAM policy set up, but your application technically needs only 3 policies, but you have got about 10 or 15 of those permissions defined. So with this MCP tool, we hope the AI agent can particularly like run your application. It can run certain tests. It can find those least permissive policies and figure out like what policies or what permissions you don't particularly need. And it's going to automatically suggest to you that, hey, maybe let's remove that out, and let's try to like just trim down the whole permissions that you're basically spending on. And finally, we want to make this whole development lifecycle more intelligent, more conversational, where you don't have to like deal with a lot of local stack specific CLI commands or with a lot of platform specific things that you have to learn. AI agents can particularly do that for you, and they can do that very, very well. And I guess with this whole demo and with this whole experiment, with this whole project that we have ran, I guess it's a very good validation to have basically pushed it out. And finally, we are trying to expand on the usage. So definitely take this up, configure it on your AI client, Cursor, Amazon Q, Cloud Code, whatever you're using right now, and let us know your feedback. We definitely want people to like be trying out this MCP server and letting us know what they're using it for. We've already gotten so much amount of positive feedback from the community out there, and we definitely want to build on whatever you are looking out for. So I guess that brings us to the end of this session. Feel free to drop in any questions you have got in the YouTube chat or the LinkedIn comments. And you can definitely connect with me on any of the social platforms. We are also on Slack. So if you have got any feedback for our MCP server, please drop us like a ping on the Slack, or just like send us a note either privately or on the help channel. We would definitely appreciate that. Thank you.
Some harsh. I'm so excited about this tool because I think the thing that you and I talked about a lot is how you have to remember so many different things. Not like it's not local stack specific, but like if I like want to say, well, tell me what lambdas, or like can I actually invoke this lambda, you have to be like, oh, what are the flags, dash dash this, dash dash that. Oh, and I need to reformat my payload because I need, etc. for like the command line. And it's tedious. And I'm
Exactly.
really excited about the way that you could just kind of now do this with just regular chat commands in plain English. So yeah, it's really awesome.
Yeah, and not just chat commands. I guess Cursor has also like dropped in a support for voice input, so you can technically say that, hey, do this for me, and yeah, it would try to do it for you, I guess.
Yeah. So yeah, well, I don't see any questions, so hopefully people will give this a shot and give us some feedback. So please give it a try. I linked already the blog posts that were mentioned as well, like the release blog post for that and the demo that he provided as well, are both in the chat. And with that, we will go ahead and jump to Kiah's session. So I'm bringing Kiah onto stage. Yeah. Hi, Kiah.
Hello.
All right. So you're going to show us what the heck is chaos engineering. So like, slides
Yes.
here. Right.
You
Add to
know,
stage. Why is this? Sorry. Lazar's usually here doing this stuff. For those people who don't know and they're watching, like we have our who's usually managing stuff on StreamYard, and they've changed the way some things work, so I'm like less knowledgeable on StreamYard. Anyway, I'm learning. All right.
all good.
Oh, and yeah, for Harsh, there's a question actually from a LinkedIn user. So if maybe Harsh will take that on now behind the scenes. All right. I'll turn it over to you, Kiah.
All right. Thanks, Brian. Hello, everybody again. So let me start with a question. And this is going to be a little bit of a funny considering the recent events. When was the last time that your system failed? Maybe a region went down. Maybe a dependency timed out. Maybe your highly available service wasn't super highly available. We've all been there. Clearly, we all have. That moment where everything's on fire, dashboards are red, PagerDuty's blowing up, and somebody says, wait, this wasn't supposed to happen, right? We're running on AWS, we're running on Azure. Like, our cloud regions aren't supposed to go down, but they did. We are here now. The truth is, most outages aren't caused by things that we don't know. They're caused by things that we think we know. We think our retries will handle it. We think our failover is going to kick in. We think our alerts will fire, but we never actually tested any of that, did we? We test features, we test performance, but we rarely test failure. And that's why chaos engineering exists. It's not about breaking stuff for fun, you guys know. Like, that would be silly. It's about uncovering truths about that your system's been trying to hide from you. And it's how we move from I hope this works to I know this works. So before I show you how to do this, let's unpack what chaos engineering really is and why it's not nearly as reckless as it sounds. Let me reintroduce myself, you guys. Kiah Imani, full stack developer. No, that is not a typo. I do consider myself a full stack developer. Senior developer advocate at LocalStack. What I love about my role is I am at the intersection of community and code. And so I'm able to, talk to folks in the community, hear their stories. And that's why I love my job. But anyway, back to the definition of chaos engineering. All right. So there's a definition that I really like that says chaos engineering is a discipline of proactively experimenting on a system by injecting controlled failures to uncover weaknesses and build confidence in its resilience to real-world stresses and outages. That is a mouthful, but let's unpack it piece by piece. Okay, first, proactively experimenting. That is the big mindset shift, guys. Most teams learn about their weaknesses when something breaks in production. Chaos engineering flips that. Instead of waiting for faults and failure to find you, you go looking for it. You form a hypothesis, just like a scientist. If this dependency fails, our app should recover automatically. Then you test it. It's not random, it's research. It's a scientific method, but applied to reliability. Next, injecting controlled failures. That word controlled is doing a lot of the heavy lifting here. Chaos doesn't mean taking production down for fun, right? This is not the Hunger Games. It means introducing small, contained faults with clear boundaries And most importantly, a kill switch. You're saying, let's fail DynamoDB calls for 5 minutes and see what happens. Not let's YOLO a whole data layer. Controlled chaos is the difference between learning and losing sleep. Then we get to uncovering weaknesses. Every system has hidden assumptions like this API will always be available, or this retry logic will eventually succeed. Well, chaos engineering brings those blind spots to the surface. When you inject a fault, you're not creating weaknesses, you are revealing them. So maybe your retries pile up. Maybe your alerts never fire. Maybe your fallback logic doesn't actually fall back. That's the stuff that chaos exposes so that you can fix it before your users ever notice. So the goal here isn't failure, it's confidence. So every time you run a chaos experiment and your system holds up, you build trust. Trust that your failover works, trust that your alerts are meaningful, and trust that your team can respond fast when things go wrong. That confidence is worth its weight in gold, you guys. It means you can deploy faster, sleep better, and know that you've already rehearsed the worst case scenario. So when it happens, you're not surprised. Finally, real world stressors and outages. The chaos that you're testing isn't hypothetical. And I'm sure you can, from recent events that things actually do happen. And this stuff happens in distributed systems every day, whether it be network latency, timeouts, expired tokens, region outages, bad deploys, the list goes on. So instead of waiting for those problems to hit production, we recreate them safely in an environment we can control. And that's what I'm going to show in the demo. I'm going to use a LocalStack's Chaos API Chaos API and Chaos Dashboard to simulate a real AWS service outage and see how our system is going to respond. It's not theory, it's practice. We're going to break it on purpose. And by the end, you'll see how that builds confidence in your system and how you can see how your system behaves when the real world gets messy. But to really understand why chaos engineering exists, we have to rewind all the way back to 2008, back when Netflix still ran everything in their own data centers. In August of that year, a single database failure brought the entire service down for 3 days, guys. Not 1, not 2, but 3. No streaming, no DVDs, nothing. I don't know about you guys, but if I had 3 days of no Netflix, I might just turn to Hulu. Like it's kind of like one of those things where you're like, you know what? I'm just gonna not use Netflix for a while, or I might cancel my subscription. So it's kind of catastrophic. So they had one database, one point of failure, and everything stopped. That outage became a wake-up call for Netflix. They realized that they didn't, test their systems well enough. So they made a radical shift, moving from a monolithic on-prem setup to AWS. And they broke their platform into hundreds of microservices, which solved the single point of failure problem, but it also introduced something new, which was chaos. Excuse me. Distributed systems don't fail in predictable ways. Networks partition, instances disappear, APIs time out. The complexity that made Netflix so scalable also made it fragile in new ways. And that's how Chaos Monkey was born. Chaos Monkey is a small tool that would terminate production instances during business hours, forcing teams to build recovery into their designs. So if your service couldn't handle an instance dying at 2 p.m., you'd know immediately while everybody was still there and awake to fix it. Over time, Chaos Monkey grew into a whole family of tools called the Simian Army, each testing a different failure mode. So Latency Monkey added delays, Conformity Monkey found misconfigurations, Doctor Monkey verified health checks. And the philosophy was simple, but very revolutionary. Break it to learn, fail small so you never fail big. And that mindset, born out of a 3-day outage, became the foundation of what we call chaos engineering. Now, that brings us to a bigger question. Why chaos? Why intentionally break something that seems to be working? Well, the short answer is because everything fails and not everything recovers. Think about how we build systems today. Dozens of services, hundreds of dependencies, third-party APIs, networks, caches, queues, database, all talking to each other. It's not a machine anymore. It's an ecosystem. And in an ecosystem, you can't predict every interaction. You can only observe and adapt. Traditional testing can't cover that. Unit tests check to see if the function returns the right value. Integration tests check if components talk to each other. But none of that tells you what happens when your network flakes out or a region goes dark or a dependency starts returning garbage data. That's real life. That's where chaos engineering lives, guys. Chaos engineering is how we take unpredictable failure and make it predictable. It's how we answer the question, what really happens when that thing I depend on disappears? What really happens when US East 1 goes down? And there's another layer here, the human one. When your team only ever experiences failure during real incidents, every outage feels like a crisis. But when you practice failure and you run chaos drills, you turn panic into muscle memory. You don't just test your code, you test your people, you test your alerts, you test your runbooks and your culture. That's powerful. That means you can face failure calmly because you've seen it before. The goal isn't to prevent outages because let's be real. That's impossible. But the goal is to make sure that outages don't surprise you. Because the truth is, reliability isn't about avoiding failure. It's about recovering when it happens. And that's how we do chaos engineering. So we can stop being afraid of failure and start learning from it safely and on purpose. Okay, so let's talk about what it actually looks like to grow into chaos engineering, because nobody wakes up in the morning and says, you know what? Let's inject failures into production today. Chaos engineering isn't a switch that you flip. It is a maturity curve. It builds over time as your confidence grows. And we call this the chaos maturity curve. And it starts at the very beginning, at stage 1. You are not even thinking about running chaos experiments. Like, it's about hardening the basics. You're adding retries, graceful degradation. You're following your cloud provider's well-architected framework. Maybe you just finished moving from a monolith to microservices, or you're still getting your observability stack together. This stage is about building the guardrails before you test them. You got to put those training wheels on before you start riding that bike, right? If you don't have monitoring and you don't have metrics, you're not ready for chaos. You're still getting your system to stand up straight, which is a good first step. Once you've got good engineering hygiene, you're ready to level up to observability. You can't run chaos if you can't see what's happening, right? So at this stage, it's all about visibility. So getting your logs, metrics, and traces to tell you the story of your system in real time and actually understanding what that means. So it's where you start defining what normal looks like. Because if you don't know normal, will you ever know when you've broken something? The goal here isn't perfection, it's awareness. So once you can see, you can start to self-heal. Stage 3 is where resilience starts showing up in code. Auto-scaling policies, health checks, fallback paths, maybe feature flags for partial outages. The system starts handling small failures automatically without waking somebody up at 3 a.m. But you're not chaos testing it. You are preparing for it though. You're building safety nets so that when things go wrong, which they will, they fail gracefully instead of catastrophically. And finally, at the top of the curve is where the fun begins. So you've got observability, you've got recovery mechanisms, and now you can start proactively testing your assumptions. This is where you start running controlled chaos experiments. This is where you're injecting small failures, watching the response, measuring recovery time, and improving it. Maybe you're using Gremlin or AWS Fault Injector Simulator in production, or if you're, of course, running locally, you could use LocalStack's Chaos API to simulate AWS outages safely without running the risk of a real incident. So I could stop here and leave you with theory, but chaos engineering is about evidence. So let's treat our system like a lab subject. We're going to form a hypothesis, inject a failure, and see what happens. So here's the setup. A simple CDK app using S3, SQS, Lambda, and DynamoDB. It's a simple, reliable pipeline disguised as an inventory management app. And we drop a file of product records into S3. A producer Lambda parses it and publishes one message per record to SQS. The consumer Lambda pulls messages from SQS and writes each of them to DynamoDB. And if anything goes sideways, SQS buffers the work and routes dead messages to that dead letter queue so that nothing gets lost. And we'll use the chaos dashboard to inject 3 kinds of failures and observe what happens. But before we break anything, let's confirm our steady state. So what we'll do here is we will trigger the pipeline with a sample CSV file. Once we do that, we'll check to see if the consumer Lambda did its job. And if it did, DynamoDB should have new items. All right, so we have a clean, steady state. Upload to S3, messages flow through SQS. DynamoDB fills up, local, fast, repeatable. And now that we know our happy path works, let's start injecting some failures. Okay, time to cause some trouble. So for our first experiment, we're gonna target DynamoDB. We're simulating a provisioned throughput exceeded exception. You might see this in real AWS systems when your write capacity runs hot, usually during like a traffic spike. It's basically DynamoDB saying, slow down, buddy. I can't take any more writes right now. So our hypothesis here is that if DynamoDB starts throttling, our consumer Lambda should retry and eventually succeed with no data loss and no panic. Just a graceful backup. And so in the demo, I'm going to inject fault using the chaos dashboard. But if you prefer to do that programmatically, you can use this API call. It basically lets LocalStack know to return a DynamoDB throttling error whenever a get item, query, scan, or put item call happens. Okay, so Now, so we're going ahead and running our experiment. And once we do that, we are going to upload a sample CSV again to kick out the flow. And watch what happens. Instead of the system collapsing, you'll see retry messages in the logs. And the pattern that you see here is the messages back off instead of hammering DynamoDB. And that's what we want. We confirmed our retry logic is working, and transient throttles don't cause data loss. And actually, once we run the happy path again, we're going to see all of our data come right back. So don't worry. All right. Next up, we're picking up on SQS. So managed queues are super resilient. AWS does a lot of the heavy lifting, but there's still a dependency. So what happens if the queue itself starts throwing a 503 service unavailable error? Well, our hypothesis is if SQS goes down, the producer should keep trying again until it's healthy. Let's see what happens. Okay, so we're running that chaos experiment. SQS is pretending to be down. So to trigger it, I'm going to re-upload that same CSV file. With SQS returning 503s, our producer should retry its sins, and our consumer should back off. So this experiment shows that our queue logic handling is resilient. What we're going to actually do is go see our dead letter queue. And what we'll see is messages that did not actually get delivered to DynamoDB, but they're actually being stored in our dead letter queue. Well, what we want to notice is if our dead letter queue count ever like skyrockets during chaos, it's a clue that our producer Lambda might need a smarter retry or exponential back off logic. Okay, so far we've broken our dependencies, but let's break ourselves. Sometimes the failure isn't in SQS or DynamoDB, it's in our own code. So we're gonna simulate a 500 error, just like when a bad deploy slips through CI. And this is like a generic one, right? Our hypothesis is even if our app throws a 500, users shouldn't lose data. The system should raise an alert and retry safely, and then recover once it's healthy again. So let's inject our chaos and re-invoke the flow. We'll upload our CSV again, and we should immediately start seeing 500s in the logs. And that's good, because silent failure is worse. We want the visibility. This is where our alerting and SLOs will start kicking in. So even though the front end might see a 500, the back end is isolated, so no cascading failure. If this were in production, users might see a nice, friendly try again later page instead of a full crash. All right. So the most important part here is what every chaos engineering experiment needs is the kill switch. Chaos engineering isn't just about breaking things, it's about controlling that blast radius. So after each experiment, we reset the environment by running this command to remove any injected faults. And that's how we can make sure that the next test starts clean. And we always rerun the happy path afterwards just to make sure that the system really did recover. If it doesn't, it tells us that our failure handling stayed broken even after the fault ended, which is its own bug to fix. So let's rerun it now. And we're scanning our DynamoDB table to see, okay, so what we're seeing is every chaos experiment that we've run, all of our data, like now that our system is healthy again, all of our data was saved. So all of those messages that were in a dead letter queue, as soon as our system became healthy again, were passed to DynamoDB like they should have been. Okay, so let's zoom all the way out. So we started this session by asking a question, a simple question. Why would anyone intentionally break their own system? Well, now you've seen why. Because breaking things on purpose is how we learn to build systems that survive the unexpected. In our first experiment, we throttled DynamoDB, improved that our retry logic could take the heat. In the second, we knocked SQS offline and confirmed our producers and consumers didn't lose messages. And finally, we crashed our application and through internal 500s that were handled gracefully. That brings us to the bigger picture, chaos maturity. Running a few experiments is great, but chaos maturity is about turning that into a repeatable habit, turning it from theory to muscle memory. So if you only learn one thing from this talk, let it be this. Chaos engineering isn't about breaking production. It's about building the confidence to know that your system can take a licking and keep on ticking. Break it safely, learn fast, recover faster. That's how you climb that chaos maturity curve. Thank you all for listening to my talk. And I will open up for questions. And if you scan this QR code, you'll get the resources for this presentation.
Awesome, Kiah. Thank you so much. That was great. I think, I generally knew a little bit about chaos engineering. I understood the basic concept, but I loved the way that you framed it where, that whole, that's a multi-phase process rather than just like, oh, hey, I'm going to just start breaking things. Have to kind of be ready to break things.
Exactly. You have to be ready to break things. But the beautiful thing about LocalStack is that you can run your chaos experiments on a production-like environment without having to run it in production. A lot of people are really scared about that. Like, I've done this talk before and I got a lot of questions about, hey, like, I'm really scared about this whole production idea. And it's like, if you run your app on AWS or, you can use LocalStack and basically replicate your production environment and with some nuance, because it's never going to be exactly like production from a traffic perspective, et cetera. But at least you'll be able to start building that confidence without having to start from production.
Yeah. I mean, you could. I think the process would be you run that test chaos experiment on your machine, and if it works right, then you at least know, you're at least fairly confident that hey, if I run this in production, I'm not going to break everything. Yeah, because I remember when I first learned about chaos engineering, to me it was like, wait, so break things in production, like, because that was the plan, right? You
That's the premise.
breaking production, yeah. So like breaking it locally first seems at least to give you kind of can take away some of that fear, I guess, is what I'm saying.
It gives you peace of mind. It's like, all right, so let me actually like run it here on my local machine, and then you can exhale. You're like, okay, all right, everything didn't break.
Exactly.
So yeah, absolutely.
Awesome. Well, thank you so much for the presentation. And y'all, that's gonna be it for our presentations today. So thanks to Harsh, thanks to Kiah for being here, and thanks to you for showing up. We had a few questions in the chat. We appreciate that. If you have any questions after this, please look for us on the our Slack channel. So it's the community Slack. It's localstack.cloud/Slack, and you can find us there. So otherwise, we'll see you next month. We'll be announcing our next month's meetup soon. Look for information on our mailing list or on the Slack. We'll see you soon. Bye.